Hi, welcome back to Engineering Drawing. I'm Dr. Vasu. We are going to discuss the projections of points, some typical problems. If you want to learn this and many more interesting topics, please do subscribe the channel. If you like this video, please hit the like button. That will keep me motivated to make many such videos in the future too. Now, let's see some typical problems in the projections of points. Let's take a problem here. A point 30 mm above XY line is the plan means top view of 2 points P and Q. So we take the reference line here and mark the point 30 mm above the XY line, reference line. So at a distance of 30 mm, we marked a point here, and that is the top view of P and Q. So we mark the P as well as Q, top view. The elevation means front view of P is 45 mm above the horizontal plane. So at a height of, in the same projector, the projectors of front view and top view of any point will be on the same projector that is perpendicular to the reference line always. So from the reference line, we mark 45 mm, and that is the front view of point P dash. Okay, and while that of Q is 35 mm below the horizontal plane, below the reference line, we get at a distance of, this is 45, at a distance of 35 mm below the reference line, we get the, below the HP means we get the front view. So the distance is marked 35 mm, and draw the projections of the point and state their position of reference. That is where these points are lying, right? So if you have to specify the quadrant where it lies. Coming to the point P, it is lying in the second quadrant because both the projections, front view and top view, are lying on one side and above the reference line. That's why it is in the second quadrant. So point Q is, yes, as you guess it, it is in the third quadrant. Front view is below the reference line and the top view is above the reference line. Okay. Now, next, state the quadrants with the help of a drawing in which the following points are situated. Point P, top view is 40 mm above XY, above the reference line. Draw the reference line. Mark 40 mm here, right? That is the top view. That is point P, small p only. So the distance is marked 40 mm. The front view is 20 mm below the top view. This is the top view. From here, at a distance of 20 mm, we have the front view. So the distance 20 mm is marked here, and the front view of point P is marked. So obviously this point will be 20 mm above the horizontal plane. That's why this distance also you can mark. So the point is in the second quadrant because both the top view and front view are lying on one side, that too above the reference line. Next, Q projections coincide with each other. Okay, so if you take a point here, right, and 40 mm below the reference line, below XY, at a distance of 40 mm, we mark a point here, right? When both the front view and the top view are coinciding at the point here, and the distance is 40 mm. So because these two projections are lying on one side and the two below the reference line, this point Q must be in the fourth quadrant. So like this, the given data should be represented as it is. Once you represent it, we can automatically get the position of the points. Okay, next. 2 points M and N lie in the vertical plane. Okay, so we draw the reference line and point M and N lying on VP means when you see this in the top view, both the top views of M as well as N lying on the reference line like this. So the point M is above HP. So if you draw a projector here, the point M above HP means front view. In the front view, we see above the horizontal plane. So somewhere here on this projection, right? On this projector, the point M front view, that is M dash is lying. Okay, that somewhere we don't know. The position is not given. Just it is above the reference line. That's all. Now, N is 40 mm below the horizontal plane. So here, if you draw a projector here from N and N dash will lie on the same projector. So we draw a projector here and at a distance of 40 mm below the horizontal plane. So here we mark 40 mm distance here from the reference line. So this intersection point here lies the N dash, the front view of N. And also the line joining the perpendicular distance between their projectors means M dash, this is one projector, N dash, this is another projector. The distance between these two projectors, right, is 60 mm. So we mark this point M and N such that the distance between them should be 60 mm. Now, the line joining M and N makes 60 degrees with the XY. M and N, of course, they are here, right? The line joining M and N here, it is making 60 degrees angle with the XY line, right? So, from N dash, we draw a line here at 60 degrees angle with the reference line, like this. If you draw a line at a 60 degrees angle, this line intersects the projector here at a point here, that is nothing but M dash, right? So from this, we can mark the front view of the point M. Now, you can measure the distance of this point M above the horizontal plane, and that is this. You can measure and write the value. So that's how we solve this problem. Just represent the data as it is given, and we'll automatically get the solution like this. Next. 2 points R and S are on HP. On HP means if you see them in the front view, they lie on the reference line, right? If they are lying on the vertical plane, their top view will be on the reference line, like that. So the 2 points R and S are on HP. Draw project reference line, XY line, and mark it R and S. 2 points. R I have fixed this point R here, right? Because its front view is lying on the reference line. I know I have fixed R, some point here, R dash. S dash also is lying on the reference line somewhere. We don't know where it is, right? It is not given. The point R is 35 mm in front of VP. That means its top view is below the reference line, right? At a distance of 35 mm. So mark the point R here, the top view of R, and at a distance of 35 mm, right? So we get R. R dash projector has come. The projections also we have marked. This is the front view and the top view. Now, while S is 50 mm behind VP, means when you see it in the top view, it is lying on the above the reference line. So at a height of 50 mm, we draw a line here to the reference line at a height of 50 mm. Now, the line joining their top views, already the top view of R is known, and S is lying somewhere here on this line, right? S is lying somewhere here because the point S is lying behind the vertical plane at a distance of 50 mm. So parallel to this XY line, if you have drawn a line here, the top view of S must be somewhere lying on this line. Somewhere we don't know, right? Let us find it. The next data is line joining their top views. The R, S top views. R we know that is fixed, and S we know that is somewhere here on this line, but exact point is not known. But RS, the top views are joined. It is making 40 degrees angle with the XY line, reference line. So what do we do? we draw a line from R at an angle 40 degrees here. When you draw a 40 degrees angle here, this intersects this line at a point here. This point, this is exactly the point S, the top view. And if you draw a projector here onto the reference line, this point will be S dash. Earlier, we know that it is lying somewhere on this reference line, but exact position is not known. Now, exact point has come. Exact position is marked. So S is here, the front view. So the front view of S and the top view of S, front view and the top view of R are marked here like this. So find the horizontal distance between the projectors. These two projectors. This is one projector and this is another projector. You are asked to find the distance, horizontal distance between these two. So you have to measure this distance and write here. That's how we get the projections and the required data. So like this, we can solve the typical problems in projections of points. We are going to see some more typical problems in the next video also. So hope you had understood this topic very well. And if you have any questions or queries or any suggestions, please do comment and do subscribe to get alerts. Thank you.